Dog's Eye here once again, and this video is going to be about testing here using these SRNE inverters behind me. I've had these installed here for about a week, but I did some testing here this past weekend and did finally get my grid input hooked up, so I was able to test it under grid power also. If you like what you see here, hit the like and subscribe button, and thanks for watching. Let's get started. So this should be a pretty good test. I've had this old Champion here for 38 years. I bought it used. It's been unbelievable, but it's a 5 horsepower motor. That's the third motor that's been put on it. Pump has been overhauled at one point here. I put new rings, valves in it, everything. I got some bigger compressors, but this one should be a good test, so we're going to see if it'll start it. Well, this is my base load. You know, this place takes a lot of power every day, so basically all the lights are on, computers are all on in the office, so you know it definitely takes a little bit to run this, you know, and I'm not sure I'm going to be able to generate enough power with like almost 9,000 watts panels every day to run it here in the winter time, but we're going to find out, see what happens, but you know, so I guess we'll get the test started here. We're going to start loading this thing down and see what it can do. So I'm going to kick compressor on. There might be some background noise here. We'll see if it kicks in. So after about 2 seconds, I had to turn it off. It would start spinning it, but it just couldn't get it up to speed. And it didn't surprise me any. I had pretty well planned on this occurring the whole time, but you know, it is. Let's test her out and see if she can do her. You know, I mean, granted, it's a high frequency inverters, you know, and a low frequency, you know, like a Quattro or something, probably would have handled it. Maybe, maybe not. To be fair, though, there's 100 and probably 30 feet of wire this has to run through to get power from here all the way from the inverters, because there's about 45 feet, 40 feet from the inverters to the former main panel. That's now going to be considered a sub panel, but it leaves from there and goes over to another sub panel in the shop, and then it runs from there down to here. So from that sub panel to here is, I think, 6-gauge wire, and from the former main panel to that sub panel is 1-gauge wire. You know, and I ran through a voltage drop calculator using just 6-gauge, you know, and about 130 feet, you know, and it come out, you know, it's getting up there close to 3%. So, you know, I kind of figured it probably wouldn't do it, but you know, let's test it. So what's going to happen here is that I'm going to run this off a grid. My plan was already to mount a panel on the outside of the wall opposite my main panel now, and that'll become the new main panel. And I explained in the last video, or 2 videos ago, I believe it was, probably in part 3, what I was going to do there as far as that panel, and it has the pass-through lugs on the bottom where, you know, it'll be through the bus bar inside and off the 200 amp breaker on the outside panel, and that'll feed my now sub panel inside the shop. So everything else seemed to work. Welder, everything else worked good, so, you know, I'm pretty happy. But anyway, let's move on and get that panel installed. I'm supposed to get a break in the weather here on Friday, so I'll get it done. I got everything all ready to roll, so later. One more thing to add here. I don't have AC input to the inverters, and I know it'll automatically enable switching over to grid if it's an overload occurs, so I just might try it just to see if it works. But anyway, you know, like I said, it doesn't really matter to me, but it might help somebody else out there. So I'll check it out. I'll test it and see what happens. So we're on another good size load here. I got a lift here. There's a vehicle on it. Let's see if this one works. Doesn't appear to be a problem. Yeah, that works good. So that's not an issue. So I'm in the office. Went ahead and ran the welder here, and then come in here and look, see what my peak draw was. 7,000 watts almost. So had a pretty thick piece there of 1.5 inch stuff. So I ran on there and it didn't phase the inverters a bit. I could hear them spooling up though, when it started kicking in on the amps. But I haven't tried the TIG welder yet, so maybe later. All right, I got AC input breaker box wired in. Of course, basically running in 2 gauge, and then I'm splitting it off here for 6 gauge on each one. I just ran my ground up for my inverters. Didn't need to run it here from the outside breaker box, but that's all wired. This is ready to go, so I'm gonna get everything fired back up. Got my covers back on, so we'll get started. Okay, this is inverters and with grid input connected, but I don't have it set for grid assist. And that was a fail too. So this is going to be setting 34, and it says when item 1, which is setting 1, is set to utility, PV is used first to charge the battery, and then to supply power to the load. In case of superfluous energy, thanks to the anti-reverse current function, PV power will not be fed back into the grid under mixed load. I had it set on disable here on the other tests, but anyway, definitely not going with on grid because I don't have an interconnection agreement. But we're going to try mixed load here, and it's just a test. After this, I'll change it back. Okay, this is with setting 34 set to mixed load. So I'm standing back here so you don't get that fan noise, but you can see that the grid power is always at 123 and the inverter output is 124. I would think that it would always be drawn a little bit from grid in order to keep that bias from sending any energy when that big inductive load kicks off here back into the grid. But either way, they're going to get it, I guess, anyway, if I run it straight off grid, but whatever. But I'll take a look here at Solar Assistant, and we'll look again at how much watts it's drawn from grid at all times. So, as we can see here, it's drawn 148 watts at all times. I would assume that, and adjust the voltage to try and keep it from backing up onto the grid, but I don't know. I don't have an interconnection agreement, and I should try and capture it. Maybe it would feed back. I could put a ammeter on there. I don't know if it'll catch anything. So this is the Inrush current on these aims here. This right here indicates it's Inrush. So it was 141 amps on just one leg, and then you wonder why the inverter can't handle it all by itself. So I'm showing like 4.8, 4.7, but I wouldn't trust this meter 100%. I probably should go grab one of my other ones. But sitting here, without even on the wire, it reads 3.4, 3.3, 3.2. I should go grab one of my scopes or something. Let's see again. So 4.2, 4.4, 4.5, 4.6. Okay, maybe it just keeps adding up, So we got 4.8 minus. See, still keeps climbing. Yeah, I know. And so here we're looking at probably a amp and a half here of standby draw. So you're looking at about 100 and some watts. And here I'll quick measure the other leg. And there's your other leg. How high will it go? Oh, 5.3. And let's see what we get here. I'd say about 2 amps or so, 240 watts, 250 watts. Yeah, I don't know if solar assistance reporting it the same or not, but you know, it's got to be around there somewhere. But you know, whenever I have this meter and first turn it on, it always will say 0.27, 0.21 amps, you know. And if you bump over the range, you know, this is what you get. So, not a huge amount of draw, you know, even if it was 3 amps, you know, you're looking at 360 watts. But you know, it's always drawn. So, just something to keep in mind in case you want to use that function. Me personally, I don't intend to. I'm going to run my air compressor direct off the grid, and I don't have to worry about any big inductive load turning off and any possibility of a backfeed when it turns off. So they will backfeed some. Whether or not the meter detects it or not, I don't know. If the utility company pulls in here tomorrow, well, I guess I'll find out. So yeah, you know, it's kind of interesting here. You know, I still have it set on there. You know, and it's showing 773 watts from grid. You know, I mean, I'm surprised it varies that much, but you know, it's not a mode I'm interested in using. For some of you, it might work. You know, if you don't want to rewire like I did and put an external panel out there so you can feed grid power to your really bigger loads. So. Anyway, I'm going to switch it back, and I doubt I'll ever switch it back on again. So, later. So I was a little confused on exactly how the mixed load function works. But, because I kept seeing the amps climb, and then on the solar system I seen like, you know, the 735 watts, you know, and I thought, boy, that's kind of strange. Basically what it does is it uses all PV that's available to power loads, and then it supplements it with using grid power. If PV is not available, then it'll draw all power to power loads from grid. It only will use the battery when grid is not available. So, you know, it's a function for somebody that wanted to use the inverters as a UPS. Basically, you're drawing off of grid power, and if grid went down, then it would start using the battery power in addition to the PV power. But yeah, it'll power loads directly off PV, but if there isn't enough PV, then it'll start drawing from grid and not from the battery. So just something to keep in mind if you want to use that mode. I personally wouldn't find it very useful because I'm trying to power all my loads with PV and battery. But somebody might, you know, want to use it as a UPS, and that probably would be a good function for that purpose. So that pretty well concludes all the load testing here on those inverters. You know, I'm sure there's going to be a lot of you out there saying, hey, you should put in a low frequency inverter. Hey, I wasn't interested. So, you know, I could have put in, you know, like 3 quattros. Yeah, it probably could handle it. I could probably put in 3 of these SRNE and it probably handle it, you know. I mean, I'm not concerned. I never intended for the inverters to run the air compressor. And I do have several large loads that are going to be on that same sub panel, although not big, large inductive loads that'll have to start, but they still draw plenty of power. And big thing here is being able to get this all recharged. You know, I'm running out of spaces here to actually put up PV panels. So, you know, and I'm not putting them on the roof. I'll guarantee you that. If you've watched my other videos and know what I do as far as winter, there's no way I would even think of it. So I know there's going to be others out there saying, oh, yeah, you should have put that low frequency inverter in, you know, and I'd have started it, you know, and I'm going to be just smiling and saying to myself, hey, what works for me may not work for you, and what works for you may not work for me. These are pretty quiet. I don't know if you can hear them running in the background, but they're running right now. They've powered just about everything else I ever wanted. I even went out to the back shed and never even gave it a thought. Back there I got a 12-inch miter saw, and I went to use it and forgot it was even on grid or inverter power, and heck, it handled it no problem. You know, that shed is powered by the panel here in this shop. So pretty impressed, and as time goes on I'll update, but these have worked really well. I'm pretty happy. So anyway, later. Some interesting thoughts though was that I should have seen possibly the inverter switch to grid power, you know, before on just a regular setting and with grid connected because an overload occurred, but it never did. And you know, and I was kind of like, well, that's pretty strange, but I don't know whether it's a problem with the software inside this unit or what it is. But like I said, I wasn't planning on running it that way. So as time goes on here, I'll probably finish showing some of the other things I need to finish up here yet. But most of it's done, and we're moving on. It's been a long project. I still have 3 more batteries to build yet whenever the cells arrive here. And I got some other things to finish, such as being able to transfer power from the shop to the house and the house to the shop. So you might have caught some of that. You've probably seen some of the boxes there and stuff, but that's for another video. And thanks for watching, and catch some rays, and we'll see you later. Find out. So like I said, what works for me may not work for you, and what works for me may not work for you.